our class. Okay, Philip, your yawning has been recorded. Okay, so everybody, let's look at the second page of the homework together. And let's go over them one by one. So I'm going to share Jessica's homework from last time because, is it Jessica or Philip? Because he has good handwriting. Small, but neat. Okay. So are we all looking at the same page?
Yes.
Okay. All right, so it says write a rational function with the given characteristics. So the hints are given. With the given hint, we have to come up with the final function. Okay. So there are no zeros, which means, okay, so Robert, if there are no zeros, what does that mean? In our rational function, what happens? Nothing cancels, right? Nothing cancels. A whole, oh, sorry. There are no zeros. There are no zeros means there's no x-intercept, sorry. Zero means x-intercept, right? When y is zero, okay? A whole exists, that means there's something cancels. I got confused. So a whole exists means there's something that cancels, okay? And here, so this is where, this is Philip's work. So this is where Philip got this equation, 2x minus 3 over 2x minus 3, because if you plug in negative 3 over 2 into x here, then you would get a 0 on the denominator. Okay, but because it's a whole, you write it at the top and the bottom, right? And vertical asymptote is at x equals 1, which means that one of the denominator must be x minus 1. And horizontal asymptote is at y equals 0, which means, okay, Eddie, what does this mean? When horizontal asymptote is y equals 0, what does that tell us about the function? Come on, Jacob.
The denominator is bigger than numerator.
What of the denominator?
Degree of the denominator.
Perfect. So if you look at Philip's answer, 2x plus 3 over 2x plus 3 times x minus 1, the degree of the denominator is bigger than the degree of the numerator. This looks fine. Let's check. So 2x plus 3, 2x plus 3, 2x plus 3 times x minus 1. Okay? X minus 1. So we know there are no zeros, right? It does not touch the x-axis. We know the whole exists at negative 3 over 2. It should be negative 3 over 2 is 1.5. It's right here. And here there should be a whole, but Desmos doesn't show you the whole. But 1.5, that should be a whole. And vertical asymptote x equals 1. And horizontal asymptote x equals y equals 1. Because there's horizontal asymptote, that's one of the reasons why it does not have zeros. It does not touch x. But my question is, Petra, do you see the Desmos page screen right now? You don't?
No.
You don't? Okay. I was going back and forth. I was just doing it all by myself. 어떻게 바꾸지? 화면 공유하는 거를 한 번에 바꿀 수 없을까? 공유 중지밖에 없나요? 이렇게. Okay, do you see it now?
Yes.
Yeah. Okay, so this was Philip's answer, and it looks correct. It meets all the characteristics. But my question is this the only answer? 혹시 다른 걸 해볼 수 없을까? Think about this. Philip, you think about it too. Can this be another function that still has the characteristics, but is different from this? Anybody? Okay, so let me try if this would make a difference or not. 자, 여기다가 뭐 할 거냐면 I'm going to square this thing. Okay, so if I square this thing, I go back to here. 그래프랑 같이 보여주면 좋겠지만 it doesn't work like that. So there are no zeros because there was a horizontal asymptote. 만약에 여기가 주석. So if I put a square there, right, and the graph looked like this. And there was an asymptote here at x equals 1. Okay, an asymptote here at y equals 0. And there still can be -3/2 a whole here. Because it didn't give us it didn't give us the coordinate, it just gave us the x coordinate. Right? X value. 근데 만약에 아까처럼이었으면 얘가 이렇게 밑에 있어가지고 여기에 홀이 있었죠. So 홀이 달라지는데 everything else would be the same. Okay? You can actually do this. 3, 4. So no matter what number you plug it into the exponent here, the degree of the bottom is always bigger. That means it's going to give us the horizontal asymptote at y equals 0. Does it make sense? Yeah. Okay.
Yes.
All right, let's go to the next one. Next one, you guys solve it for me. Okay, so there is a 0 at 6. Jessica, what does that mean? There's a 0 at 6.
It means that the x-intercept has 6.
Good job. X-intercept to 6,0. 6,0에 그래프가 pass through 합니다. 이거죠? Okay. A hole exists at negative, right? X equals -3. 그건 이거죠? 지금 동화가 쓴 거. X plus 3가 cancel 된 게 위아래 다 있어요. Okay. No vertical asymptote means, what does that mean? No vertical asymptote. Robert, you want to try?
You should not put anything. No. 모르겠어요.
Well, you're getting there. You should not put any variable in the denominator,
Yes.
except for the one that cancels. 만약 여기 x가 있거나 x 스퀘어드가 있거나 x 플러스 1이 있거나 하면은 항상 there will be at least one number that's going to give you an undefined, which is a vertical asymptote, right? But no vertical asymptote means 밑에 안 되는 숫자가 없다는 말이에요. Okay, horizontal asymptote at y equals x minus 6. Y equals x minus 6. That's not a horizontal asymptote. That's actually a slant asymptote. Okay. So when do we get a slant asymptote, Eddie? When do we get a slant asymptote?
Bigger than 1.
What's bigger than 1?
뭐지?
the degree of the numerator is bigger than
numerator.
degree of the denominator, right? By 1. 그렇죠? 1이 커야지 이렇게 직선으로 나와요. 리니어로 나와요. 만약에 위에 degree가 2 크잖아요? 그럼 어떻게 되게요? 슬랜트 에시미토시 어떻게 되게요? 이렇게 되게 신기한데 생각하면 되게 신기한데 얘가 지금 1이 커요. 1이 크면 이렇게 직선으로 나오거든요. 슬랜트 에시미토시. 근데 위에 degree가 2가 크면 슬랜트 에시미토 비슷한 게 생기는데 어떻게 되냐면 이런 식으로 그래프가 패스할 수 없는 공간이 생겨요. 오케이? 그래서 그래프가 이렇게 그 주위로 가거나 아니면 뭐 이렇게 가거나 이렇게 되거나 이런 식으로 막 돼요. 그래서 that's 슬랜트 에시미토스의 변형이야. 이게 이거가 2 크면 이러고 이거가 3 크면 어떻게 될까? x 큐브드 모양으로 슬랜트 에시미토 같은 생겨요. 지나갈 수 없는. 오케이? 자, 오케이. 그래서 this is Phillips answer and I like it. You cancel. 그래서 홀이 여기 있고 no vertical asymptote 밑에 캔슬되니까 아무것도 없고 horizontal asymptote x minus 1 여기 위에 degree가 1 크는 거 맞고 0가 6에 있으니까 x minus 6에 있고. Okay? 이거는 I don't think we can create any other function like this one because of this part. 꼭 1 커야 되니까. Is it? Is it? Yeah, I think so. Okay, let's go to number 7. Esther. Esther, when it says the zeros are at -1 and 3. 그렇죠? 무슨 말이에요, 얘는? 뭐가 있다는
x 인터셉이 -1이랑 3라는 거예요.
아니에요. zero가 뭐죠, zero가?
응?
zero가 뭐지?
그 x 액시스 지나는 점 아니에요, 이게?
맞아요. 그게 뭐라고 그러지?
근,
이름이 뭐지, 걔가?
해?
해를 떠나면 뭐라 그러지?
x 인터셉.
x 인터셉트가 2개 있어요. 여기 하나, 여기 하나. That's why Philip wrote this. 그럼 이 x plus 1이랑 x minus 3는 should it go to numerator or denominator?
Numerator.
Good. 그리고 vertical asymptote x equals 0에 있어요. Jacob? When there is a vertical asymptote x equals 0, that means
The denominator should be x because when we put 0 to the denominator, it becomes 0,
it becomes undefined.
undefined.
Almost, I was gonna say perfect. It's 0, so not perfect. Okay, if you plug in 0 into x, this function is undefined, not 0. Okay, all right, good. Next one, the 0 is at 2. Okay, good. 0 is at 2. Vertical asymptote at x equals -2. Okay, so that's where you got this one. And x equals 0. That's where you got this one. And horizontal asymptote at y equals 0. Okay, 이것도 아래가 더 크니까 y equals 0 성립되죠. Okay, Philip, is there any other answer that's possible?
I don't know.
Think about what happened here.
Put the square
Go around
the denominator.
denominator. You can put square here or square here, right? Or put
Yep.
fourth power here and then square here. It's not gonna affect these characteristics. But are these changes going to change my graph? What the graph looks like?
Yes.
Robert, what do you think? If I put 4 here and 2 here, do you think the graph changes?
Yes.
Yes. Why do you think so?
I heard Thomas say yes.
Okay, because if you plug in a number to the original function, 여기다가 만약에 1을 넣었을 때랑 2하고 4가 있을 때 1을 넣었을 때랑 아니면 10을 넣었을 때랑 값이 달라지잖아요. When the xy values change, your graph doesn't look the same anymore. Okay, right. Let's scroll down. 자, 동원이 거의 다 했네. Good job. Okay, so let's look at this one. This might be tricky for a lot of you who are very confused about this one. Do we have Brandon? Okay, Brandon. 자, 일단 동화권은 답이 다 써 있으니까. Actually, let's go to the actual question sheet. 자, 답이 없는 것을 해볼게요. Okay, Brandon, work with me. So you're supposed to write a rational function with a given graph, right? Note points shown are holes, not points. Okay, so we're gonna come up with our function for this one. Okay, so give me the first hint you can find from this graph.
First, we can know the vertical asymptote, which is -3.
Okay, so what does that tell us?
And then we could, the denominator maybe, is that in the bottom? Yeah, that becomes x plus 3.
Perfect. All right, Jacob, give me another hint.
There's a horizontal asymptote in y equals 1/2.
Okay,
And then we know that in order to get the horizontal asymptote, the degree of the numerator and denominator should be same.
Mhm.
So we plug numerator to x, and then we have to add 2 in the denominator.
Like this.
Yeah.
Okay, good. Is there another hint, Jessica?
It has to be negative.
It has to be negative. How do we know that?
Because the parent graph is different from that like 1/x is opposite to that graph, it needs to be negative.
Okay, let's hold on to that thought, okay, because it's not always that way. Okay, there's another hint from the graph. Let's go to Robert. Can you find the last hint?
Oh,
Think of fair. What are we missing from fair?
I actually only got two hint.
Okay. How about Philip? Philip, can you give me the last hint from the graph? Okay, no. Actually, I can help Robert. Robert, the horizontal asymptote, the vertical asymptote are the only things we got so far. Okay, that's the part. But what about this part? Can this help us write the function?
Yes, x integer. Intercept.
X-intercept is what?
-2.
It is -2 comma something. So what does that give us? How can we change this part?
X plus 2.
X plus 2, there we go. Oh, I think I gave you the wrong, I think I just wrote X in the answer key, but it's it should be X plus 2. Okay, because of that right there. But Jessica, here's the thing. If we put that into the graphing calculator, I'm gonna say X plus 2 over over 2x plus 3, that actually gives us this kind of graph. Okay, you don't need the negative. So and if you think about it, if you put negative there, if you put negative there, it's going to give us something like that, and our horizontal asymptote would be down here. Okay, so it kind of changes the whole purpose, finding the horizontal asymptote. Okay, so that has to be positive. Okay, all right, good. So we got the answer. So I think Jessica got the right answer for this one. So let me ask Jessica, what is the first hint we got?
Vertical asymptote.
Okay, vertical asymptote where?
X equals -1.
X equals -1. So what does that give us?
The denominator is x plus 1.
Good job. X plus 1 has to be there in the denominator. Okay. Eddie, can you give me a second hint?
Second into hole.
Oh, there's a hole here. So, from 뭐야 돼요? Where is the hole? What is the x value?
-2.
So, -2. So what does
맞아.
2, comma -2?
x 플러스 2.
2. 여기랑 여기랑. Okay, good. Esther, what is the next hint?
The horizontal asymptote is on the y equals 2.
Okay, y equals 2. What does that give us? What does it tell us?
It means that the coefficient of numerator is 2 and the coefficient of the numerator is 2 times bigger than denominator.
Okay, and what else does it tell us? If you have horizontal asymptote that is not a 0,
Mm-hmm.
what about think about the degree of each numerator?
They have same degrees.
They have to be the same degrees. Okay. Okay, so we are missing something here. Okay, let's go to Brandon. Brandon, so we have vertical asymptote, horizontal asymptote, we have the hole, and there's more hint.
Yeah, the with intercepts.
Which intercept? X-intercept, Y-intercept.
Aren't there both?
Yes, so there's X-intercept here, the Y-intercept here, but we want X-intercept first because it's easier to make the function. So it's at X -3, so how can I write it here?
And maybe it can go on the top, like x plus 3.
3, there we go. Now, it looks like it's almost perfect, except we have to check this point. So 0, 6 has to be one of the solutions of this graph, right? So I can plug in 0 into all x's, and I'm going to get 4 times 3 is 12 over 3 equals 4. Something is not right. 7 used to be. Or is it? Okay, so that was actually the answer I got before, but it looks like it's the wrong answer. Wouldn't you agree, Philip?
Wait.
It has to be 2, same degree, -1, poles cancel, -2, -2. So if you plug
Yes.
if you plug in -2, we should get -2. Does that happen? If you plug in -2, it's -1, it's -2 over -1, so it's 2. So that does not hold. So we need something else. What can we do? Ooh. What if I do this? What if I put a square here and a square here? Would it change anything? 해보자. 영을 넣어보자. 그러면 it's going to be two times two. 수는 없어졌구나 아까 전에. 6. Actually we don't need this. 선생님이 아까 전에 실수한 게 뭐냐면 캔슬 안 한 상태에서 계산을 했네요. So that's why it was weird. So if you plug in 0 into the factored form, that's going to give us 6 that holds. What about this one? -2, -2, -2 times -1 over -1. That still gives us 2. That's weird. Very pure. Does anybody have any idea about this one? Why this doesn't work? Or what we can do to the equation here? Okay, let's all think about this for one more minute.
-2로 -2로 나오지 않나요?
If you plug in -2,
Yes.
그러네요. Why? Okay, so this holds. Okay, so I was just a bad calculator. Okay, so everything holds fine. Everything's good. So 10 is okay. Thank you, Philip. Okay, let's go with this one. 자, 이건 좀 빨리빨리 가봅시다. Okay, so Eddie, first hint. Always vertical asymptote이 제일 쉬운 것 같아요.
vertical asymptote y equal 3.
3하고 and y equals 3. X equals 3.
X
X equals 1. Okay.
3하고 -1.
Tell us. 그 말은 밑에 뭐가 있어야 돼?
x 플러스 1 x 마이너스 2.
3. Okay. All right, Jessica. Next one. Horizontal asymptote at y equals 3. So that means we have to have a 3 here, and we have to have some 2 degrees, the x to the second degrees here. Okay. 자, 다음 힌트 뭐가 있을까요, Jessica?
x-intercept 0, 0 and 4, 0.
Okay, so x intercept place. What does that tell us?
X and x minus 4.
X minus 4, and then it's x here. Yep. That's it? Yeah. Okay, good. 자, 이거 해봅시다. Let's go to Brandon. First hint.
We can know the asymptotes
equals
X equals 0 and 3.
okay. So what does that give us? In the denominator,
Yeah, we get 0 and x minus 3.
good. Let's go, Robert. Next hint.
X-intercept? No, I'll go vertical asymptote.
Vertical asymptote 여기 있잖아 방금.
Yeah, horizontal asymptote.
Horizontal asymptote. Where is the horizontal asymptote?
0.
What is 0?
Y is 0.
Y is 0. What does that mean?
No, 안 써요.
No answer?
No, we put 0 at numerator.
We put 0 in the numerator? No, this means the degree of the denominator is
Bigger.
bigger than what?
Numerator.
The degree of the numerator. Okay? Do we have,
Yes.
okay, so another hint, boys, another hint. Let's go back to Eddie. Another hint.
4.
홀. So 1,2 홀이 있어요. So what does that mean?
X minus 1
X
equals
minus
to
1
1
밑에도 X minus 1.
밑에도 X minus 1.
Okay. Good. 자, 여기서 끝인가요? 마지막 해야 될 게 하나 있어. 뭐 있을까? Esther, can you tell us what is one more step we have to do? It looks like the bottom degree is bigger, so this checks. We have 0 and 3, this checks. Okay, we have a hole, so that checks. 그냥 하나 더 해야 돼. 뭘까? 뭐만 해보면 돼.
We have to wait. We have to check the 홀을 집어 넣었을 때 맞아야 돼.
누가 맞아야 돼요?
그러니까 홀에 x value 1을 넣었을 때 2가 나와야 돼요.
맞아요. 때리지 말고요. 자, n을 넣읍시다. 뭐가 나와요? 뭐 나와요?
-2.
네게티브 2가 나와요. 그렇죠? 이건 캔슬 됐으니까 없었으니까. That's actually one. So that's not the right value we want. 그래서 -1/2에다가 뭘 해야 얘가 2가 2가 될까요?
Multiply -4.
Multiply by -4. 그렇죠? Good. So we're going to multiply -4 here. And that's our final function. Make sense?
Yes.
Okay. 자, 원래 빨리 하고 오늘 숙제를 가려고 했는데 시간이 다 가버렸네요. Okay, so you guys have no homework today. Let's just go over some of the questions tomorrow on the homework you did yesterday, and then we'll spend some time on solving questions about limits. Okay, and there will be some homework over the weekend because we have no class on Friday. Right? Okay, 수업은 이것으로 마치도록 하겠습니다. Good job, guys.
Mr.
Thank
Kim,
you.
Yes.
do we keep on doing aha note?
Yes. 오늘 아하 아침부터 써주세요.
Okay.
네.
Okay. Bye bye.